So, welcome all at Kaunas University of Technology, Santaka Valley. I'm very glad that at 6 p.m. we have the full room and we have exciting coming 2 hours with the people that really are exceptional, that are bringing in extraordinary topics. And I just want to say that as Kaunas University of Technology, we value very much this event because it really represents something that is really international. A part that we have here, as I can see, our international students, but also we have world-class experts, speakers from Germany, from UK, from USA, and USA, I understand, New York and Boston. Also, it is something that is very important on Kaunas University of Technology strategy is interdisciplinarity. That is also represented by these events. So really bringing together arts, bringing together technology, and helping us really to break through our minds. I really expect that we will be able to expand our worldview, and to have a wonderful time. So I would like to present Gediminas Urbonas, MIT professor, as he will be leading the event together with Tracy Wall. And let us have wonderful 2 hours for this weekend. Welcome.
Hello, my name is Gediminas Urbonas. I am an associate professor at MIT Art, Culture and Technology program. Thank you very much for coming to the first of the series of ZOOETICS lectures, in which we are seeking to unpack, re-evaluate, and recombine the notions of nature, Anthropocene, and interspecies. Thanks to our partners at KTU, Kaunas Technology University, for hosting this event, and especially Asta Punzene, Vice Rector, and Violeta Kauneliene, and all research groups at KTU joining this investigation, this project, and also UTempus team, my partner Nomeda, and Victoria, for helping this to happen. Thanks to MITA, Mokslo, inovacijų ir technologijų agentūra, the Agency for Science, Innovation and Technology, and Lietuvos Kultūros Taryba, Lithuanian Council of Culture, and EU Frontiers and Retreat Project for their financial support. Podcast of the lectures will be on our website, zoetics.net. We invite you to interact with the project as it develops through our online reading group. The format for this session is that we will have 45-minute lecture from our first speaker, Christianas Schwägerl. And Christian will take 2 quick questions from the audience at the end of his talk. Then we will have 45-minute lecture from our second speaker, Natalie Jeremijenko. And Natalie will similarly take very quick 5-minute questions directly after her lecture. Then we will have 20 minutes for panel discussions between the 2 speakers, you, the audience, and myself and my ZOOETICS colleague, Dr. Tracy Wall from Oxford Brookes University, who is research and professor there in UK. Tracy will moderate questions after the lectures and during the panel. The lectures and the panel will be in English. And I would kindly ask you, as there are more people coming, to please, in respect to our lecturers and also your colleagues trying to listen, please turn off your mobile phones, your cell phones, turn the sound, the ringing sound. Thank you. So I'm delighted to first introduce Christianas Schwägerl, who is a prize-winning writer on the environment. He is based in Berlin. His book on the Anthropocene was published in German in 2000 and translated to English this year. He was an external curator for the Welcome to the Anthropocene exhibition that opened, in fact, yesterday at the Deutsche Museum in Munich. Please help me to welcome Christian.
Thank you, Gil. And thanks for reminding me to switch off my own mobile phone, so I'm not disturbing myself. It's wonderful to be here. And can everybody in the room hear me well? Is that good? Fine. The word Anthropocene is. We need to switch this for.
I think you have to turn a bit
closer. Okay. Is this better? Super. No. I will switch to the other microphone, I think. So let's see. Okay. This technology in the Anthropocene, it's always the microphones where the problems start. I think there should be an own department of microphone technology in every university, but wherever you go, the microphones fail. Good. So this word Anthropocene, I'm curious, who of you has actually heard about it before you became aware of this evening? Be honest. Wow. Okay. So I think this is pretty representative, and you don't need to feel bad if you haven't heard it before. In fact, where I come from, the Deutsche Museum, one of the world's largest technology museums, they did a visitor survey last year ahead of the big exhibition, Who Knows Anthropocene, and 90% of their visitors didn't know the word. So what I will try to do in the next 45 minutes is to give you an overview, a bit of a journey into the Anthropocene, tell you what it is, how scientists explore it, but also what it could mean for us. And it's important for me to make clear that this difficult big word is not something abstract. It's not something far removed and just a global thing. It is something that is very much connected to our lives. And I have three main words I'm trying to connect to the Anthropocene. One is sense, one is sensors, and one is sensitivity. And they're all related, but they come in from different perspectives. So Anthropocene as a word, it has two parts. Anthropos, the human being. Every one of us is an anthropos, and it is kind of a signifier for the human. Scene comes from the Greek and is a word for the new, kainos, actually quite similar to the name of your town here. That becomes in scientific language scene. And geologists, and this is where the Anthropocene idea comes from, geologists use this syllable scene to describe a new epoch, a new chapter in Earth's history. So Anthropocene means something new that's connected with us humans. Now, we do know that Earth has a very long history. We are living on an old planet. This planet is 4.5 billion or 4.4 billion years old, and the matter we consist of here, the walls, the chairs, you, everything you wear, has been around for not only that period, but for much longer, going back to Big Bang and the evolution of elements. But our planet formed 4.4 billion years ago, and it took some time to develop what is known as the biosphere, this ever-changing, ever-evolving, interconnected thing. So what we see since very recently, so that's the scene, the new, is a transformation of planet Earth that comes through our species. And some people call this the noosphere, the sphere of knowledge. Now, as you all know, we humans, we are very new on the planet. Now, we speak of 200 years of Anthropocene, but our species perhaps is only 200,000 years old, and that's nothing in Earth's history. It's just the very last second of Earth's history. So imagine what you consist of, your body consists of, the carbon, the hydrogen, the other elements. They have gone through all this evolution. They have been different organisms. There have been plants and dinosaurs and bacteria, everything. And now the human species is reorganizing matter and becoming ever more dominant on Earth. We have tried to make sense of our appearance on Earth. For the time human civilization has developed, we have developed spiritualistic, animistic cultures. We have developed a belief in one God. We have developed an idea of enlightenment. We have developed an idea of humans creating their own system, the industrial economic system. And only very, very, very recently, so in that second that we are on the planet, in the very last millisecond, our species has developed a sort of global consciousness of who we are and what we are doing with this planet. In fact, the image you see here, which is now so ubiquitous, almost that you get bored when you see it, planet Earth, you know, it's used in logos and Google Earth and everywhere, and people kind of get bored from it now. 50 years ago, this was not even existent in that way, and it was a very dramatic political activity to actually get NASA to publish this, and it really changed a lot in the way we view ourselves. Now, as I said, Anthropocene is coming from the realm of geology. Are there any geologists in the room? Anybody working with geologists? No, okay. So this is good because I'm not a geologist myself, so makes it easier for me. I'm a biologist, by the way. So Anthropocene is a story that is told in rocks, but it's a story about life. So it's not a dead story, it's a story that is very much alive. It's a story that shows that what we depict as nature, untouched nature, the paradise nature that is sold to us in tourism, is about to cease to exist. This idea of an environment that is around us, that is this big thing where we can dump things into, where we can dilute things into, where we can make the effects of our civilization vanish into, where we can extract resources from without consequence because the resources are endless. This idea of an environment is about to end. And here this image shows the sort of idea of a typical untouched nature. In the Anthropocene, we are going to see touched nature. Now, this strange word was coined by two men, one I show here, The other one, his name is Eugene Sturmer. He was a limnologist in the US. And he had kind of used this word informally for quite a while, but not really much in writing. And in a kind of congenial way, this man, in the year 2000, and so this idea is really that new, Paul Crutzen came up with it at a scientific meeting in Mexico, a scientific meeting of the International Geosphere Biosphere Program. And there were colleagues of his talking about our current geological epoch, the Holocene, which basically started with the end of the last ice age 12,000 years ago. So there were people together who are used to kind of dividing up Earth's history into these big chapters, you know, the Jurassic, the Trias, and so on. And the very latest epoch, the one we live in, and you might have kind of learned that in school, is the Holocene. And Paul stood up in that meeting and said, look, you know, we don't live in a Holocene anymore where there is this big nature around us. We humans, we are so strongly influencing, changing nature, changing planet Earth, that we are living in the Anthropocene. And this had a big effect on the audience, because this idea of human civilization living in like islands and doing just scratching Earth's surface a little bit is still very strong. So what this idea of Paul Crutzen symbolizes is that really we change Earth fundamentally. We change it on the geological timescale, and that is a very big timescale. So what you should know about Paul Crutzen is that the fact that we can walk around in summertime, under the sun, still today in the 21st century, we can very much owe to him, because he really has an interesting story. He never received a formal training in chemistry, but he became a Nobel laureate in chemistry. He was a civil engineer building bridges in Amsterdam. And then he met his wife in Switzerland, and he was at the opening last night of our exhibition, and they retold that story that they had an 8-minute window to meet on that mountain in Switzerland. Otherwise, they would have missed each other and not married. So Paul would not have gone to Sweden with his wife, and he would not have applied to a job at the Institute of Meteorology in Stockholm, where they looked for a computer programmer, and this was in the late 60s. So computing at that time was still very in its initial phases. Now, the thing was, Paul didn't know a thing about meteorology, he didn't know a thing about chemistry, and he didn't know a thing about computer programming. But he knew he wanted to enter the natural sciences. He couldn't have gone into it because of the war, and because his parents were too poor to pay his fees to become a natural scientist earlier on. So he became the civil engineer to build bridges and earn money. And he saw that as a chance to enter academia. And so he applied and he got the job. And because there were no other computer experts around, and within a very short time, he made an amazing career and became an atmospheric chemist who researched the ozone layer. So he's the man who started research into ozone and this sort of protective layer that protects our planet from UV radiation from space and really makes life on land possible. And his research really contributed to finding out that there are substances that harm the ozone layer, and that it was high time to do something about it. And Paul Crutzen, together with 2 other Nobel laureates, that really laid the scientific fundament to save the ozone layer. And this scared him like hell. This experience that we humans produce a substance, the CFCs, for good reasons. I mean, this was like for refrigerators and sprays and climate controls and air conditioning. So very good, very nice applications, but the substances were so dangerous. And this was not, nobody had thought about it. So this idea that we are harming the Earth's protective layer more or less unknowing really scared him, and he started to make very long lists of what else we humans do. And this then led him to diagnosing the Anthropocene in the year 2000. And together with this other researcher, he then found out that Eugene Sturmer had used the word as well. So they linked up, and in the year 2000, they published a paper called The Anthropocene. And this is how this idea entered science in a formal way. So basically, this now is, first of all, a scientific hypothesis that there is a new geological era starting with us that is symbolized or that expresses that humans change the planet not only globally, but systematically. So we are not just damaging something here and there, but we are fundamentally changing the workings of biology, chemistry, geophysics on the planet, and that for a long time. So even if our species was to vanish mysteriously from Earth overnight, still somebody who comes back in 100,000 years or in 1,000,000 years even could see that something has happened. This takes me to sensors, because our wonderful scientific development in the past century has given us a wealth of knowledge about global change. The idea that one could count the number of people on Earth is pretty new. And the records now kept tell us a story of human expansion. So we are now at 7.2 billion people. And in pre-industrial times, there were perhaps 1 billion people. And we are heading to 11 billion people by the year 2100, if the current trends continue. And this alone creates a huge change, because we are now the dominant vertebrate species on Earth. So if you take away the idea of like soul and human dignity and so on, and you just count our weight, our simple gravitational weight. At the beginning of the Holocene, humans and their animals, at the time the wolves, they were just a few % of the biomass of vertebrates and mammals. Now we are at about 97%. If you count together the animals we keep for our food and ourselves, if you put that on a scale and weigh it, we now make up 97% of vertebrate biomass, and the wild species make up only 3%. I'm not saying we have overpopulation. I'm not a big fan of this idea. I'm just saying this is a big factor. So look at this wonderful city here. You might recognize it's Paris. Cities now cover something like 3% of land surface, which is quite a bit. Cities are a very effective way of living together. But if you look at it from an Anthropocene point of view, this is man-made geology. This is stones that have been brought together from all parts of France and probably North Africa and far beyond to build this city. And any city is a concoction of materials. So if in 100,000 years or 1,000,000 years a hypothetical geologist comes back, he will find a funny mixture of stones in some places, sediments that arise from our cities, layers of stone that are the former cities. This shows how cities are prognosed to expand in the next decades. And in the top left corner, you see a city that expands in eastern China, right along the coast, over 1,200, 1,600 kilometers. The same in West Africa, where there is a city growing that is 600 kilometers long, at least. Now, our industrial age has brought about huge changes in the surface of Earth, and this shows forest fires in the Amazon. So we have cut, I think, about half of the forest that had been developing after the last ice age and are still continuing to do so, not only in South America. Look at this picture. The red shows deforestation between the year 2000 and the year 2012. 12 years. And these areas have lost their forest. In the center, a lot of it is due to fracking, the extraction of methane gas in a novel way. A very geological intervention, by the way, if you think about these boreholes that are used for oil extraction and fracking. We've produced something like 50 million kilometers of boreholes on planet Earth. And when biologists look back in the history of life, they find these little holes dug by the primeval worms, the first multicellular organisms, and they can detect, oh yeah, there have been worms around at that particular point in time 500 million years ago. So think again about this guy or this woman who is researching Earth in 100,000 years. He or she will find millions of kilometers of huge boreholes, mines, oil extractions, tunnels, and so on, railroad tunnels, and you name it. And perhaps the hypothesis will then be that we have been gigantic worms digging their way through the mountains, where in fact we have built this wonderful technology to help us. Now, I don't need to say much about climate change. I think you're all familiar with that. And this again is an intervention on a global scale. It is an intervention that goes deep into time. And current models say that there will be, if trends of carbon dioxide emissions continue, there will be enough carbon in the atmosphere, and if methane from the seafloor is added to it, there will be enough warming potential to actually phase out the next ice age. So one might say this is a good idea, that planet Earth will not go back into an ice age. But let's look at it neutrally. We have now the power to phase out the next ice age. That's a pretty new thing, and we know about it. I mean, organisms before us have done similar things, like cyanobacteria. They have changed the composition of Earth fundamentally with adding the oxygen we now breathe, but they didn't know much about it, probably. We are in a state of becoming aware of what we do. Now take plastics. Plastics are a very recent innovation, and they have been super beneficial for our lives. But as you all know, plastic pollution is a global problem now. It disturbs wildlife, birds feed on it, and this is what happens on a remote Pacific island, one of the remotest Pacific islands of all, Midway, where seagulls feed on plastic, and they die from it. Now, this is a biological effect, but just look at the mass. We have produced enough plastic in the last 100 years that you could wrap the whole planet in plastic film, in cling film. So, I don't know if you know the artist Christo. He has this project to wrap things, right? Like he wrapped the German parliament some time ago in plastic. So you could wrap the whole planet in plastic. I already talked about mines, and this is an example where humans produce aluminum. We are all familiar with aluminum, but it might still surprise you that humans have extracted enough aluminum oxide, which is then turned into aluminum, from geological sites to cover the United States of America completely in aluminum foil. And what remains are sites like this, where for a long time you have like a geological imprint on the surface of Earth. So there are a number of statistics now that represent this fundamental intervention we humans carry out. And one important is that we've now changed 75% of Earth's land surface. So only 1/4 is what you would still call untouched, if there is any. And I'm not saying touching nature is bad. I'm just saying it's touched by humans. It's changed by humans. And even in the Amazon, where environmentalists think the Amazon is untouched rainforest, the opposite seems to be true. Where it's cut now, where the trees are cut and you have open space, more and more places, scientists find the relics of former civilizations that have lived in these areas. So even the Amazon is like secondary forest in parts. And a very striking example in the bottom right is, of course, nuclear waste and nuclear bombs. And at the moment, scientists look at really defining the beginning of the Anthropocene with the first nuclear bombs, because we have added a huge amount of new elements to Earth with the nuclear explosion starting in 1945 that have fallen down and become part of the geological record, where you can really say, when you look back, there are new elements in Earth history. So this is what nature could be called in the Anthropocene, like fields in Brazil, artificial islands, settlements that are extending over huge areas, or mountains that have been reshaped, actually capped for coal mining in the United States. And we turn what we extract from nature into products that have, again, a very long life, like electronic waste that then ends up in Africa. So when I use my mobile phone, this is, when you look at it, it's an amazing geological thing that takes me very close to nature. So in the mobile phone, you have something like 40 different elements, copper, gold, silver, and so on. So think of the mountains these elements come from. Think of the mines these elements come from. And then you hold the sort of 40 mountains you're connected with when you have your mobile phone on your ear. You then throw it away because Vodafone gives you a new mobile phone every year now, right? You throw it away and it ends up near that girl in West Africa. And people there try to make a living from processing it. But it then becomes part of the geological record there, because it will be, the landfills will stay for a very long time. This is fields, flower fields in the Netherlands. And so this idea of changed land surface has led one researcher, Earl Ellis from the University of Maryland, to again come up with a new word. Biologists speak of biomes when they describe sort of large-scale habitats for plants and animals. And he came up with the word anthromes, so human-dominated landscapes. And they now cover, as I said, 75% of land surface. Now, the sea surface, you would think that the oceans, they're still kind of untouched in a way, until you study the effects of bottom trawling. And actually, the trawlers that get the fish out of the ocean for us, they use techniques that are very similar to tractors that plow fields. And so the area that has been plowed by these trawlers is almost as big as the area used for agriculture on land. So when you go down to the bottom of the ocean, you find human-made changes, fundamental changes to the habitats down there, that because the ocean floor conserves a lot of the changes, will be visible for a very long time. And we are adding technology to the planet. I've talked about the smartphones, but really the smartphones are only a very tiny proportion of the technology we produce. And again, I'm not saying this is something bad in itself. The Anthropocene, first of all, is just describing that this is happening on a global scale, and it has long-term systemic effects on our planet. Same you can say for evolution. We humans are now smart enough to intervene in evolution. When Charles Darwin laid out his Darwinian theory of evolution, it was all about chance and blind change. So the big provocation of his time was that evolution has no destiny, that there is no aim with it, that it's an aimless process. But suddenly our powers to control life have become so big that we start to intervene in evolution. And you see, I mean, the rainbow rose, or the banana, or the bonsai tree, or even the chicken, they're all sort of part of our culture in one way or the other. Animals adapt to what we do. This is a crow's nest from Tokyo. And the crow is using hangers that you get in dry cleaning. You know, when you pick up your things, you always have the aluminium hangers, and then you don't know what to do with it. So people that discard them, and the crows start building nest with it. Birds in Mexico City start building cigarette filters into their nests because they contain nicotine, and the nicotine wards off parasites. So they deliberately collect cigarette filters and build them into their nests now. This is a good example of how our technosphere can actually enrich the biosphere in a very, very strange way. Now, this is a crocodile I've seen a couple of weeks ago when I was in San Francisco. And it's just a very strong symbol of human intervention in the organismic world. It would probably not live long if it was in the wild, but it is a very strong expression of human forces, because these white crocodiles, they only arise through interbreeding in zoos. Now, this is a genetically modified fish that is called glowfish, and it's actually a pet by now, so you can buy it. Again, I'm not sure if you set it free. Natalie knows much more about that, how long it would live, but it does show, you know, we can create organisms at will. And this is actually the next stage, synthetic biology. So you might have heard the name Craig Venter, a leading molecular biologist, and his team. They have put together the genome of a bacteria synthetically in the lab, and the aim is to produce designed organisms with traits that we want. That looks a bit scary or funny or whatever, however you want to see it. It's a military cow, and it's meant to help soldiers navigate difficult terrains in Afghanistan or wherever the United States Army wants to move. And it represents a big trend that has very positive sides, that we take inspiration from nature, but the application then is something different. And I'm just showing this to show you that technology is kind of homing in on life. This is very crude. I mean, this actually shows us that it's not the case, like philosophers said so long, that we are machines. One could argue that machines are very, very primitive organisms. And I mean, no machine on the planet Earth is as complex as a single cell would be. This is just a very symbolic thing. So I hope I've given you enough examples that in this Anthropocene nature, we have to be open for new phenomena. Our planet is changing so rapidly through our hands and through our minds that we have huge challenges ahead of us. And I just want to run you briefly through what I think is a very positive story of the Anthropocene. Now here you see Paul Crutzen again, and to his right, a man called Jan Salasiewicz. He is heading the Anthropocene Working Group. That's a group of scientists, and actually if you look closely, you also see me here. I'm not part of that group. It's a group of scientists that tries to find out whether the Anthropocene is not just a fancy idea to express the power of humans, but that it is also a geologic reality, and that in the school books of the future, we will learn that we live not in the Holocene, but in the Anthropocene. I took this group to this place in Berlin. It's a former NSA surveillance station that tried to surveil the Soviet Union from Berlin, and also, of course, East Germany from West Berlin. This station sits on a mountain of war rubble, burying Hitler's war university. So you have kind of a man-made hill in Berlin. You actually have 50 man-made hills in Berlin, again, sort of Anthropocene geology. And on top you have this NSA thing, which is now abandoned. And we are now talking to develop it into an Anthropocene kind of field station. Here you see pictures from last night on the left. Achim Steiner, the Deputy Secretary General of the United Nations, he came to Munich to open our Anthropocene exhibition, here with Paul Crutzen and his wife. And at the bottom, Jan, who is kind of leading the scientific effort to collect the evidence of the Anthropocene and to, by 2016, come out with a first formal vote whether the Anthropocene is a geological reality. Now, geologists are very conservative people, so this group has to make a very convincing case. And at the right side, you see at the bottom the Haus der Kulturen der Welt, so House of World Cultures is a cultural center in the heart of Berlin. And therefore, the last 2 years, we have brought together scholars from very different fields to debate the Anthropocene and to explore it. And at the top, you see an archaeologist discussing with an anthropologist about kind of human fossils mixed with waste and so on. You find we had 60,000 visitors in the Anthropocene project over 2 years. And it was an attempt to find out what is really interesting about this idea. Now, let me give you some indications why this matters. I have already, with the smartphone example, tried to convey to you that we are all Anthropocene actors. So whether it's the smartphone, or think of, if you go to the loo, you release phosphate into that little hole. When you think of where it comes from phosphorus mines in North Africa or in China, that it goes through the agricultural fields, that then the plants, that then become the animals, that then become you. And where it goes from you, where it goes into the river and into the ocean and so on. This is just a tiny example of how our industrial metabolism really is on an individual level. All of us are part of this Anthropocene story. But there is also a big side to it. And I'd like to name 5 or 6 points why the Anthropocene is interesting. The Anthropocene idea places human history right into natural history. So far, you have historians that kind of explore what happened in the Middle Ages and what happened around the birth of Christ and so on, and they work on the documents. And then you have the biologists, the evolutionary biologists who study evolution. Now, this idea that humanity is now acting on the geological timescale says that Earth history and human history are one, and that one has to really think them together, in particularly when you think about the future. Now, the Anthropocene also describes all changes we humans bring about. And it's not just about negative changes. It's like, you know, there are funny things. Like some of you, I see you use ballpoint to write, right? And in every little ballpoint thingy, you have a crystal at the top that is artificial. So, I mean, I don't know how many pens you use in your life. I actually, as a journalist, use many. And I always am surprised that they vanish again. So I think about the billions of pens that we produce. And every single pen has an artificial crystal that has not been part of Earth's history before. So we will add a layer of pen crystals to Earth's history. So it's not only the bad things. The Anthropocene, in my view, is not the sum of all environmental problems. It's first and foremost opening up to perceive what we are doing. So it's about climate change, it's about biodiversity, adding biodiversity or losing biodiversity, and many, many other changes. When you look at it, you see that the more we spread as humans, the more we become the nature of the future. So our culture becomes nature, because we are now covering the whole planet. What else is nature if that what covers the whole planet? And what we used to call nature now becomes, in a sense, culture. Think about a plant that lives in the Amazon rainforest. In the middle of it, in 50 years' time, it will try and soak carbon, like all plants do, carbon dioxide from the atmosphere. Now, where does that carbon dioxide come from? It will have gone through coal power plants. It will have gone through your car. It will have gone through a lot of things we humans do. So there is this human imprint on the carbon molecules. We have taken them out of the ground, put them in the atmosphere, and then they end up in a plant. Let's say an orchid, a very tiny, fragile orchid, which is composed of elements that have gone through our hands, through our lives. So the Anthropocene kind of breaks through the dualistic nature-culture divide. It makes humans part of nature, and nature part of the kind of concept of civilization. Now you might say this is a very old thought, and nobody says everything is new about the Anthropocene. It ties into long philosophical traditions. But it's a very strong expression of this. What the Anthropocene idea also does is that it creates an image of the future. And I think that is very important, because the environmental debate, it often ends in the year 2050 or 2100. And if you look at the graphs, you know, they all go to that point in time. That's how much we know, right? And in the environmental scene, there is this idea of the eco-apocalypse, the end of the world as we know it, because we humans are so bad and we do so much damage to the planet. Sometimes I feel that environmentalists almost hope for humans to vanish from planet Earth, because then this sort of untouched nature is that's paradise. I have huge respect for the environmental scene, but this kind of disturbs me often. And what I think the Anthropocene does by putting us on the geological timescale is that it creates this deep future. So there is not even much hope, if you want to have it, that the human story will end. The human story will be very long. Climate change will act out on the next 50,000 years. So if you drive a car today, you kind of communicate with the future beings that live on Earth in 50,000 years on a very elemental level. Now, there is the word anthropos, and there is a very good criticism of the Anthropocene idea. And I'm not preaching the Anthropocene. I think there should be a lot of criticism. It should be really tested scientifically and so on. So some people, for example, say, this is a very bad idea to call it the Anthropocene, because that makes us all equally responsible in a sense that we have all equally caused, for example, climate change. And if you look at it, I mean, there is the pension fund manager who decides to put 5 billion into new oil exploration. He's an anthropos, and there is the poor guy in India who has a carbon budget of close to 0, who is not responsible for climate change. So some people say, yes, this kind of blurs the responsibility question for change. And I would argue that, yes, that's a danger, but also you could see that Anthropocene means that we are kind of all in one boat, and that it's becoming a forum for global decision making. And that is, I think, also that offers something to us. And there's another criticism that says the Anthropocene is very anthropocentric, and I think this is also leading quite well into Natalie's talk. So is Anthropocene, does it mean that we humans, we run the show, you know, we are the most important thing on Earth, or even we not only dominate Earth or are the driving force of change on Earth, we are kind of entitled to own Earth. Is that the message of this idea? No, it's not. And it means that we become aware of how fundamentally we change Earth and reflect about it. So a science historian said the Anthropocene is a process that reflects about itself. So Anthropocene means that we are becoming aware of our role. And my feeling is that the Anthropocene will be its exact opposite. It will not be the age where humans can everything, do everything, and kind of engineer the whole planet. It will be the epoch when we realize how interconnected we are with all life on Earth, with geology on Earth, how deep we are part of nature, so that technology and progress, they don't take us away from nature, they take us deeper into nature. Thank you very much.
I'm sorry to be being late, but maybe you can tell, let's say, Jeremijenko's industrial revolution and suggestions that he is proposing is the right to tackle these problems.
Yeah, Jeremy Rifkin is a very creative thinker, and I like some of his work. I mean, what he, I think, tries to do is kind of use the power of innovation to solve problems, and I think that is a wonderful approach, and it's wonderful that he, you know, he sees the powers we have developed, and he always has these ideas, you know, if you just change a little bit in the kind of economic metabolism, that, you know, you could actually use the powers that are now destructive in many cases to a good purpose, and I like that. So, for example, thinking about how to value nature economically is something, you know, he thinks about, and I share that our economy now is blind to what we get from it, and we have to kind of make it seeing. We have to kind of factor in the services we get from what we used to call the environment into our economy, and so yeah, there's a lot I like about it. Yeah. One more. Yep.
Other questions, but if we could save them for the end. Sorry to be brutal. Thank Christian.
Yeah.
Thank you very much.
Super.
Thank you, Christian, for your enigmatic talk. Now I'm delighted to introduce you Natalie Jeremijenko, who is artist and engineer based in New York. Natalie did her PhD, received her PhD from Stanford University in mechanical engineering. And also she taught at Yale and also NYU, Center for Advanced Technology, University of California, San Diego, and again, she's teaching now, she's professor at NYU. Natalie was working with Bureau of Inverse Technology and initiated a series of projects under the umbrella, the OOZ, O-O-Z, the zoo spelled backwards. Her accolades include appearing on the list of the most innovative people, the most influential women in technology, the top young innovator, and the most influential designer. Please help me to welcome Natalie.
I'm going to try it anyway. I thought that I could maybe make it work. It seemed... No, it's not. Okay. I was being mystic. I usually have a magic touch with technology. Look, it's working fine. Yeah? I think it's going to work. I'll swap this if I... Okay. Okay. All right, so briefly, it's really a great pleasure to be here. It's my first time in Lithuania, and it's been delightful the last few hours. But also because I think this is this topic that's been coined so beautifully as ZOOETICS, which is really the challenge we face of reimagining and redesigning our relationship to natural systems. Christian has given a wonderful and actually the most compelling introduction I've seen of what the Anthropocene actually is. And now the question is, what is our response? What is our response ability? What is our ability to respond to this framework, this coinage, this massive shift in what we understand our place is? Can we respond? And I think global warming or the climate crisis before the Anthropocene has also had a very similar effect, a counter effect actually. It's revealed a much more insidious crisis, what I call the crisis of agency. What to do? What do I do? What does any one of us do? What do we do institutionally? What do we do collectively? What do we do? And I think that question of what we do is the one I'm most interested in, what I'd like to talk to you tonight about. And gets at this, this problem of how we frame. When we talk about global warming, by definition, you can do nothing about global warming, right? And this is why I really like the Anthropocene as a coinage, because we get away from this idea of global warming, which is frankly depressing, right? Paralyzing. Turning off your light, changing a light bulb, reusing your shopping bag, whatever, radically necessary, but radically insufficient. And we know that. No matter what magazine tells you 10 things you can do to save the world, come on, please, right? This idea of what is it that we can do is, I think, the interesting and compelling question that we're all asking ourselves. So I'll just tell you the way I've framed my work and to create a context in which we can ask this question, address the crisis of agency, is to develop something called the Environmental Health Clinic. And the Environmental Health Clinic functions like a health clinic at a university, where people come with their environmental health concerns as opposed to their medical health concerns. And they walk out with prescriptions not for pharmaceuticals, but for things you can do to actually improve and address your local environmental health, right? So it's a familiar cultural institution. the clinic. Anyone can ring up and make an appointment, or put, online make an appointment. Right? It's not hard to. You don't have to be an environmental activist or a solid-state atmospheric physicist or chemist, or anyone can make an appointment. Now I'm what? Okay. So essentially, what we're doing is twisting the definition of health from one that is internal and medicalized and pharmaceuticalized to one that's external, in the air quality in this room, in the food systems that you depend on, in the relationships you have with natural systems, right? And frankly, there's many people that are cohering around this idea of an external view of health. Your lifespan is better predicted by how close you live to a major arterial road than it is by your genetics, right? The top 5 things that people, that pediatricians treat in New York City that take up about 90% of their office patient time. Number 1 is asthma. Number 2 is developmental delays. Number 3 is rare childhood cancers, which have increased 400-fold in the last 15 years. Number 5 and 6 are diabetes. And what's common about all those top 5 issues? The environment is implicated. None of those are what medicos are trained in. None of those are the germ theory of health, right? So it's an absolute inversion of what we understand our relationship to natural systems is, and in fact how we define health. And the promising thing about defining health in this way that's external is that we can do something about it. We can act on it. And anything that you do to improve your air quality or your food systems, the benefits are enjoyed by anyone you share that air quality or food systems with. So that's one that I'll call, I'll put in the tradition of institutional critique. But I'll also introduce you quickly to the O's, which is again taking a familiar institution, that of the zoo, and inverting it. So the O's is zoo backwards and without cages, and it's about creating habitat, urban habitat for non-humans, right? The legacy institutions of the zoos are, I would argue, radically inappropriate for the Anthropocene. And we can and must redesign our relationship to natural systems, and there's no better way to do it than with and through these charismatic organisms. And similarly, pharmacy, again, another institutional reframing, is misspelt deliberately to explore and create a context in which we look at food and food systems that actually not only decrease food miles, decrease petrochemical fertilizers, decrease pesticides, decrease the negative impact, but actually are food and food systems that increase biodiversity, improve environmental health, and generate positive environmental benefits. So we can design these. So I'll start with just introducing you to some pharmacy projects. The project that we've started with is these ag bags, which are really inexpensive ways to do closed system, soil-based urban vertical agriculture. You can see that they turn any railing or parapet or double-hung window into arable territory. Let me see, I'm keeping an eye on the time. I'll come back to this. What do you grow in an urban context? It's actually interesting. You can see here, let me show you. What do you grow in an urban context? In New York City, there's a lot of urban farming happening on rooftops and in community gardens. And the problem is with Brooklyn Grange or any of the, there's 3 major rooftop farms, that they're growing exactly the same foods as the struggling family farms 7 miles up the Hudson River who don't have hundreds of volunteers, university students who are volunteering on these rooftop farms, and they don't have the preferential access to chefs. So the urban farms are actually undermining the very rural farms, the family farms, the rural food shed that we would want to actually support. So what would you grow in an urban context if you had a non-compete agreement with the rural food shed? Any ideas? Well, I'll tell you. You'd grow something that's high nutrition value, high commercial value, and highly perishable and non-distributable. And what's that? Flowers. So flowers are the most nutrient-dense foods we know of. Their high color signals powerful lycopenes and antioxidants that the urban body needs. And you can see here, this is what farmer sees. So they're highly perishable and non-distributable, right? So if, with the black pansies here, if you don't use them within a couple of minutes of picking them, they lose all their delicate volatiles and they, they're tasteless. So we flash infuse them into vodka to make the best black pansy infused vodka you've ever had. Probably the only. But this idea that we can take these barren urban environments and infloresce them, of course, who likes flowers? Apart from you. Exactly, pollinators. And then the number one environmental health risk to you, your family, your children, air quality. Funnily, we have one demonstrated technology for improving air quality in urban contexts. Does anybody know what that is? It's a wonderful technology. It's called leaves, or leaf area index. So we have a radically inexpensive way to actually improve our air quality. So by maximizing the leaf area index, taking barren urban environments, supporting pollinators, and exploring these delicious new flower foods, we begin to look at how we can take something like this is JFK, which is the front door to New York City. And we're currently about to launch a campaign where you can purchase flowers for a railing on JFK that will say, "Dear Mum, I'm putting some flowers here to greet you. We can go and see them when you get in. I put a special message on there, with love, NYC." So we can take a barren urban environment and collectively infloresce it. It's also actually much more interesting to do urban farming while you're rappelling than to do it on your hands and knees. So I recommend it. And the flower foods are really very exciting to explore. I'll just show you a couple of the flower foods we're doing. This is flower colas, using open source cola. I've been setting up these manufactories. So a manufactory is a mashup between a party and a assembly line, right? So it sets up with pre-measured syringes, the syrups, the public water. So you move along and you assemble your own colas. I add these benign ingredients. I've taken out the non-carcinogens that are used by the big Pepsi Cola companies. These include Love Cola has New England aster flower tincture in it, which is the Iroquois Indians used as a powerful love potion and is also an antiviral. Or Happy Cola uses St. John's wort flowers in it. You might be familiar with the mind-altering effects of this. Another example of this food is Flower Floss, which stands for Free Libre Open Source Systems. And this is not sugar, this is isomalt, which is the major ingredient in Metamucil, if you have that. If you have a sluggish gut, you'll know what I mean. It acts like a fiber in your lower gut. It enables you to farm your lower gut, if you will, fostering biodiversity in your lower gut. But we also sprinkle it with bee pollen, high protein bee pollen, and delicious high nutrition value edible flowers. And we stick a color-changing LED on the inside of it to make this delicious flower floss. So the net effect of the production and consumption of this food, right, is that you not only increase biodiversity in your lower gut, you also increase biodiversity in your local neighborhood. The net effect is positive, right? We can design these good goods, these food systems that have a positive net effect. But actually, I want to tell you that the manufactories have been very difficult because it turns out that they're a lot of fun. People have had a great deal of fun at them and have done them everywhere. But it turns out that low-skilled assembly line work is not at all low-skilled. And when I do it in galleries and museums, I have these manufactories and events like this, and I get people like you to line up and go along the assembly line. There's a lot of chatter and fun and talk about the radical transparency of food production and why it makes sense. You can see what's going into your food, and it makes a lot of sense to do it in this way, except people spill things and they don't press down the syringes, they put it on the labels incorrectly. It's just a mess, right? And so I decided I needed some Oompa Loompas to help with this. And so I formed this musical theatre company called Child Labour. And now it's children that perform in musical but efficient assembly lines to produce these good goods. And that is an interesting strategy to look at hyperlocal production, where the children, of course, are performing to produce goods that their loving parents and community will purchase, but the profitability, and if you know colonomics, selling flavoured public water is a highly profitable business, but with the child labour chapters, that profit is going into the educational institutions. I want to show you this, this project called Signs of Life, which adapts the pharmacy ag bags to cross-dress buildings, if you will. And what we're doing here is actually a very simple example of a powerful idea that I never learnt I did a lot of doctoral work. I actually did 3 PhDs, and I never learnt this one very simple fact. And I've tested my students, I've tested my molecular biology friends, and I didn't know this one simple thing, that actually most of the world's biomass is composed of the subset of symbiotic organisms we call mutualists. Mutualists, as you probably know from high school biology, you probably introduced to the term, you know, both parties or all parties involved benefit from that relationship. So all of our corals, all of our forests, all of our terrestrial plants, effectively, all the flowers and pollinators are mutualists, right? I learned a lot about selective pressure. I learned a lot about competition for resources. I didn't know that that's how natural systems work, through mutualism, right? Effectively, to the first order approximation, they're mutualists. And I find it astounding that we don't know this generally. Maybe, did anybody know this fact? No. It was actually first published in 1989 in an ecosystem science textbook, and it still hasn't been celebrated. But so what is mutualistic systems design? What if we took that idea seriously? What does mutualistic systems design look like? And I want to show you this Signs of Life as a concrete example of what mutualistic systems design might look like. So this is taking a building, cross-dressing it, in a commercial sign space, right? So you can advertise whatever the hell you like, right? But printed onto the ag bags, you can promote the enterprise or the organization for whatever purposes you like. But you're also, in these Signs of Life, you are also supporting pollinators, increasing leaf area index to improve air quality and the human health benefits of that, and exploring these delicious new flower foods that I introduced you to. So that's a concrete and simple example of how we can take signage and in fact write zone, local municipal zoning. So yes, of course you can put up a public sign, but that public sign also has to contribute to the common good. It also has to support pollinators, it also has to improve air quality, right? And then we'd get the kind of mutualistic systems design. It works better as a sign, right? Because you're looking at the sign more seeing the butterflies bumping around on there. So mutualistic systems design, I think, is an important, if you remember nothing else about what I show you today, please take home this idea that mutualism is the dominant form of organizing socio-ecological systems and is the paradigm with which we can design in the Anthropocene. So let me introduce you quickly to the ooze, because creating habitat for non-humans is interesting and important. Actually, I'm jumping over this. I want to introduce you to another child labor project. This takes the phenomena of actually black carbon, which is the stuff that comes from inefficient combustion and combustion-based society. It changes the reflectance of the atmosphere and the color of snow. It's the grime that first showed us the evidence of carbon enrichment in the atmosphere and global warming. And it's a powerful greenhouse gas that is the low-hanging fruit of the greenhouse gases, because it's only suspended for a couple of weeks. It circulates globally, and it's equally produced by urban contexts and by biomass combustion in developing contexts and non-urban contexts. And we can do something about it. So I've been exploring with the Child Labour Project these solar chimneys, and I've just been exhibiting this summer the electrostatic precipitator, which sucks in the polluted air, charges the particles, and then binds them with this high voltage field that binds them to a grounded metal surface to collect that grime, right? So we take the grime through this electrostatic precipitator. And then I take that black grime, the same thing you can wipe off your windowsills, right? That ultrafine particulate matter that's so small it's not regulated. It's below PM 2.5, and it goes into your pretty pink lungs through your alveoli, circulates in your cardiovascular system, carrying with it a whole lot of other toxins. It's as I mentioned, it's a huge and most toxic form of air pollution that this species, humans, have ever been exposed to, these ultrafine particulates. So we take this grime, we inexpensively collect it through solar chimneys, put it through the electrostatic precipitator, and then I'm taking the grime and binding it with a wax and clay to make it into pencils, the length of which measures the amount of black carbon we've pulled out of the air. So, and if anybody wants to tweet, I think it'd be great to have a tweet coming from here, Lithuania, to the Metropolitan Transit Authority in New York City, that you want a pollution pencil. Dear MTA, I want a pollution pencil from the Midtown Tunnel. The Midtown Tunnel in New York City is the biggest pollution source in all of New York City, with these unfiltered vents that go straight into the lungs of children in Queens. And the MTA has not allowed me to install a electrostatic precipitator because of security risks. So if anybody would like to tweet, I'd appreciate them. You can see here, this is some of the child labor involved in collecting and making these pencils. Okay, so let me actually introduce you to some technology for non-humans. This is a perch, which is telecommunications for birds. When a bird lands on it, it'll trigger a sound file that'll say something like this.
Here's what you need to do. Go down there and buy some of those health food bars, the ones you call bird food, and bring it here and scatter it around. There's a good person. Okay.
So I've set this up in a number of different places. These perches are set up. Each one of them has a different argument. My favorite is actually the one for the copyright dues for all the melodic resources for your cell phone ringtones and other things. But the birds' favorites, in this case, this was in the Whitney Museum, This particular percher you're seeing pictured was the favorite, about 8-1. There were 6 other perchers that really allowed the birds to experiment on people, which argument would best elicit cooperative responses from the people below. And it was this one that had that the birds decided was the most effective.
Tick, tick, tick. That's the sound of genetic mutations, of the avian flu becoming a deadly human flu. Do you know what slows it down? Healthy subpopulations of birds, increasing biodiversity generally. It is in your interests that I am healthy, happy, well-fed. Hence, you could share some of your nutritional resources instead of monopolizing them. That is, share your lunch.
Okay. So let me show you, I'm going to speed up a little bit. I'm going to show you just a slew of examples of how we can redesign our urban environments. We're starting off with moth cinema. Does anybody here not know that moths are attracted to light? Anybody not know that? Right. We all know this, right? But we design our urban environments as if, we slaughter, millions of these valuable pollinators every night with the way we design our urban lighting systems. In the case of the moth cinema, it's a silver screen that hangs in a park that is illuminated by light. The light attracts moths, but instead of being fried and bedazzled, they find a moth garden that's full of host plants and nectar plants. And so they bounce around on the nectar plants, playing out their nightly dramas, their love triangles, their adventures, casting these dramatic shadows on the silver screen behind them. And demonstrating for us how and that this was actually the first lunar moth seen in New York City in 40 years at the Moth Cinema in Socrates Sculpture Park. Demonstrating that we could design our urban lighting with companion planting to address the fact that we know moths are attracted to light and to recognize their value. We could display our success in designing habitats, urban habitats that support biodiversity in this way. The butterfly bridge similarly takes the phenomena of urban biodiversity and our urban contexts have become islands of biodiversity, right? Metropolitan Paris has, with the biggest citizen science research project ever, has demonstrated that the biodiversity of pollinators in metropolitan Paris is higher than in all the surrounding rural agricultural areas. The butterfly bridge takes the phenomena of urban biodiversity, which is characterized by patches of viable habitat, these fractured patches of ecology, and connects them. So the butterflies are attracted to butterfly attracting plants. Instead of being smeared on your windscreen like butter, they are in fact, they attracted to the plants and they bounce across the road from one patch of ecology to another. Happily, butterfly overpass to provide safe passage for butterflies. In this way, of course, make the fleeting presence of these pollinators much more durable, emphasizing, of course, the cross-species crossing, putting these up in front of, over crossings in front of schools is a strategy that increases the awareness. And it really shows how we can inexpensively stitch together corridors that take isolated populations and creates the genetic flow that increases the resilience of these populations. We were getting 30 butterflies per hour, which is how you read that sign. And similarly, the salamander superhighway. Salamanders are the base of the ecosystem in northeastern United States, and they are tremendously interesting creatures, fascinating to me as an Australian, where they're like Santa's elves. They don't exist. The continent and the environment has conspired against them. But the salamanders, if you actually rolled them into a ball of biomass, salamanders and amphibians, and their frothy spawn, that biomass ball would be twice the size of the non-human vertebrate mammals. So a huge amount of flesh in the puddles and under the leaf matter and in the vernal ponds. That anyway, salamanders are obligate migratory organisms, and the salamander superhighway facilitates their migration by creating a micro speed bump that you drive over, and of course you get a little reminder that you're not alone. But they inside the salamander superhighway is a PIR sensor, so every time a salamander goes through, it might tweet to you something like, "Hi honey, I'm coming home," or in Socrates Sculpture Park, it was the Socratic salamander who would pose questions like, what comes first, the salamander or the migration route? But there's a lot of designs. This is cross species on. That's the highway on ramp. They breathe through their skin, right? So they're incredibly temperature sensitive, and they can read the thermal differential between this sign and transpose it to other contexts where they can pose. So this is how quickly they learn to read the road signs, the salamander superhighway. The biochar is similarly biochar may not be well known here, but in degraded agricultural lands like those in Australia and Africa, biochar is incredibly exciting technology that takes waste, cellulosic waste, incinerates it in a process called pyrolysis that doesn't produce CO2, it doesn't produce particulates, but it does produce syngas, a methane-like gas that's energy. So it's a waste-to-energy process that then produces this char that you can work into the soil. That char sequesters carbon for, 5,000, a million years, who's counting, something like that, which is much better than, for a forest. It'll sequester carbon for a couple of hundred years, right? So this is the 5,000-year urban plan, if you will. You take cellulosic waste, and what I did was I asked people from Long Island City, where we did this, to bring their junk mail, their business correspondence mail, their old university papers and dissertations, and come and incinerate them in the biochar barbecue. And then I invited a salsa DJ as well, so we had a biochar where we could discuss what it means to what does distributed local power production look like? Given that this is probably the biggest idea in our energy transition to no carbon context, and yet most of us don't really know what waste-to-energy systems look like, or why we would want one in our neighborhood, or how we could use it to both augment the soil. And you can see here where we worked biochar into the soil, we got a 40% increase in growth response from the lawn. Right, we're also sequestering carbon. The way it works is that it creates kind of luxury housing, high-density housing complexes for soil microbes, right, which then release more nutrients to the plants. And it also immobilizes heavy metals, lead and mercury in particular, which are powerful neurotoxicants that we have to do something about. So here we are augmenting building soil, which, as Christian suggested, is the measure of a civilization, right? And creating energy. You can take home some biochar from the biochar and put some in your front yard on one side and not on the other side, or one in one pot and not the other, and actually experiment with what this looks like. And at this kind of convivial social context, we can discuss that just with the paper waste, this recycled paper, that currently has 5 different subcontractors that handle it, diesel trucks that come through and collect the paper waste, compromising your cardiovascular health, right? And then is handled. It makes no sense to distribute waste, right? It just doesn't make any sense. But we do it over and over again. If we didn't do that, and if we had a biochar in every neighborhood, we would have enough energy just from paper waste to do all the public and domestic lighting required in the neighborhood, right? While we're building soil, sequestering carbon, supporting soil biodiversity, and improving our own health. So these are examples of mutualistic systems design, right? I want to show you a couple of sports that I've developed, because sports, I think, are a really important way that we choreograph our movement in green spaces. And I find the paradox that we design sports in New York City. Actually, most of the new sports fields have the plastic or vinyl turf, plastic turf. Do you have any sports fields here with plastic turf? Right. The argument for using the plastic turf is an environmental one, because the maintaining actual turf, monoculture turf with the petrochemical fertilizers, is too damaging to the watershed. So it's more environmentally sustainable to use plastic turf than real turf in sports fields, which is the paradox of sports in general, that we design these sports facilities that degrade environmental health while they're improving human health. And you know, so can't we design sports that in fact improve human health and improve environmental health? So I'd like to introduce you to one of these sports and invite you to think about this as a design challenge. Does anybody know who the strongest animal in the world is? Yes, most people think the ants. It's actually interesting. I don't know who their PR company was, but we should get them on board for the Anthropocene. In fact, the strongest animal in the world is the rhinoceros beetle or the stag beetle, that appear in every biome in the world, and they're incredibly strong because they churn the cellulosic, the rhizomic layer, and they lift up logs and they aerate the soil to create the kind of soil biodiversity that is so critical for all ecological function. But they're kind of unsung heroes of the underworld and difficult to interface with. So I've designed a rhinoceros beetle wrestling device, which looks like this, where you climb into the rhinoceros beetle wrestling device. It scales human forces to beetle scale and beetle forces to human scale to create a level playing field. And then you can, in fact, wrestle the rhinoceros beetle. Because if you design a sport that's dependent on non-humans, take horses, for instance, there's going to be a lot of them around, right? So I offer a scholarship to my university program to any rhinoceros beetle wrestler. And the idea that you have to, of course you actually have to have a sexy female around for this male to fight anything. So you have to have a healthy population of rhinoceros beetles to have a sport that's to take on man versus beast. And of course the funding strategy for this is to take wagers on man versus beast. And anyone who wants to lay a bet, I will take you on. Anyway, this idea that we can take exercises and training programs and sports and design them so they improve both human and environmental health is I think, extremely, fun. And I'll give you another example of some of the training programs here. This is in Long Island City, just opposite Manhattan, where small groups and individuals were each given training programs. Every exercise in their program increased human health and environmental health. One of the favorites was, for instance, for building the six-pack. I think that's pretty popular, right? And the best way to do that is with, for core body conditioning, is hula hooping. So one of the exercises was hula hooping. Of course, our hula hoops are adapted so that you fill them with New England wildflower seeds. So as you're hula hooping, you're spreading resources for perennial resources. And of course, you're much more likely to come back next Saturday to see what you've done, what's sprouted. And if the birds are there waiting for you, that funny person with the yellow hula hoop, to get their free lunch, right? This idea that you can have an effect on your ecosystem, and that can be positive. So even boys were doing hula hooping, right? And there's some genetic incapacity for boys to hula hoop that I haven't quite gotten to. So I'd like to introduce you to another organism in ooze. Actually, this organism is a executive on the Ooze Corporation. So Ooze is incorporated, as you know, in the US, corporations have personhood. By putting non-humans on the as executives of the Ooze Corporation, they of course attain personhood. And so the tree of the white oak here that is a tree office is what I'd like to introduce you to. The tree office is a co-working space or hot desking space. What do you call it in Lithuania? The kind of a maker space, you know, co-working space, right? That translates, yeah. Anyway, it has high-speed internet and locally generated power, and is an office in a tree, right? Which is a very nice place to have an office. I can tell you, I use this as my field office. But the conceit of this is that it was owned and operated by the tree. The tree is your landlord, right? So you pay your hot desking fees, your co-working fees. We had actually 40 people paying $25 a month to use this as their office whenever they liked. The tree was generating about $1,000 a month, right? In New York City, the value of the tree in the major paradigm, which is called environmental services. I don't know how many of you are familiar with this, but pretty much every city has valued their trees because of the real value of the urban forest and its air quality benefits. But in the case of New York City, a New York City street tree is valued at $400 for 80 years of service for all the carbon sequestering, habitat provisions, energy savings from shade provisions, stormwater retention, all of the services that it provides. $400 for 80 years of service. That's a very low-paid service worker, right? And I would rather a paradigm where the tree is seen as a facility, as an asset, as a landlord. It's actually a lot of fun to get hassled by your tree landlord. Will say things like, your membership fees are due, and I'm not going anywhere till you pay them, right? The tree office, we just built it. This is the tree office in Berlin at the Anthropocene curriculum that Christian was instrumental in making happen, where we actually held our seminar on valuing trees and other parts of natural systems in the tree. And of course, the legal precedence is this guy. This is actually the tree that owns itself in Athens, Georgia, auspiciously Athens, the seat of democracy, but this is the US version of Athens. And the most hopeful thing is that this tree lives there. So this was a tree that owns itself, that was willed to itself by Colonel William Jackson in 1832. He loved this tree, and he said, you can own yourself and the 8-foot plot of land around it. So unfortunately that tree died, and the Junior Ladies Gardening Club came along in 1946 and planted a scion, a sapling of the tree, the acorn of that tree. So they tested heritability laws, right? And the tree that owns itself continues to own itself and stands as a legal curiosity. And I would say a precedence for this idea that we can extend rights discourse to non-humans, which at first seems ridiculous. But I think there are ways that we can reposition trees and natural systems in our urban environment that is important to change their value. I'm going to skip through a couple of projects because I'm going to finish I've got still another 10 minutes actually. So let me introduce you to the mussel choir. The mussel choir is a choir of mussels, of course. These guys, I think actually oysters had the same PR company that the ants had, because mussels are the heavy lifters of water quality improvements, right? Mussels have co-evolved with humans. In fact, we probably owe them our neocortex. because there's the midden pile theory of human evolution, how in 40,000 years we grew these massive neocortical protrusions that so differentiate us. We needed, in order for that to happen, to have a steady supply of these DHAs and EPAs, right? It didn't happen on the plains. I mean, as we were taught, that these heroic guys with tools suddenly started hunting animals, and then we had this caloric excess that we could produce culture, what we know now, which is sort of the human evolution on the plains theory, right? Which of course depends on, heroic guys. It was probably actually the steady supply of EPAs and DHAs, the membrane-rich brain required of women and children, and probably guys, foraging in the water to get mussels, sedentary mussels that created middens. Are these huge geological scale evidence of human evolution, where humans have evolved in that space between the terrestrial and the aquatic ecosystem, that liminal space. Anyway, we can talk a lot about mussels, but they're great, and we need to redesign and reintegrate them into our urban environments instead of these hard edges. And in New York City, we have reconstructed 15 feet of shoreline in all of Manhattan Island. And I have some influence on that 15 feet, where I've been populating it with mussels who have moved in the last 2 years since we built the 15-foot shoreline reconstruction. That is not the hard edge, but a gradated edge that has tidal exposure. And on it are the mussels. So the mussels actually have a sensor, a magnet and a Hall effect sensor. So I can tell when they're opening and closing, right? Because that tells us a lot about water quality, given that their lives depend on the water quality. So we take the opening and closing of the mussels and turn it into song, of course. So this is the rock band. We've just launched in summer. I just launched this, the touring band of the rock of the mussels. These are up on stage singing away. And you might ask, well, what does a mussel choir sing? Right?
Daisy, Daisy, give me your answer too.
It sings a version of this, and actually the reason why Siri, if you ask Siri to sing you a song, it'll probably sing this. Or you remember in 2001, Hal sang Daisy, Daisy, right? The reason why is because of this guy who was the first computer synthesized voice, right? And he sang. I suppose it's a he. Siri, she, I don't know. They sang A Bicycle Built for Two. So it's become the icon of artificial intelligence, right? This, so much so that Aaron Coblin came along and anyway, this is a bicycle built for 2,000 using Amazon's Mechanical Turk, where 2,000 people are singing and they get compiled into a bicycle built for 2,000, which is, I think, a very skeptical, cynical way of representing distributed intelligence, right? So as opposed to artificial intelligence, we now have the capacity to use distributed intelligence and draw on the integrate the distributed intelligence from many people to a different song, a more hopeful song, A Bicycle Built for Too Many, which is what I would call the icon for natural intelligence and what the mussel choir represents. So So that's the mussel choir in the Venice Lagoon, where the pitch of the mussel is set at the depth that the mussel is at on this mussel sock you see here. And that's their first hit single. But there are the album is coming out soon, and I would love to get you to join their Instagram, follow their Instagram and their Facebook page. The amphibious architecture array is a similar project actually being installed in the same place, which is buoys that light up. Just let me play that for you again. When fish swim underneath. They were installed in the East River and in the Bronx River. You can see they were installed here with a always-on light at the top, which shifts from a warm red color when dissolved oxygen is low to a cool blue-green color when dissolved oxygen is high. And not only can you see that so it's a sort of a low-resolution display of fish presence. Not only can you see that there are fish there, but you can also text the fish, and the fish will text you back. But most importantly, there's always a sign when there's urban animals. Do not feed the animals. And you've got to ask, why not feed the animals? Why should we monopolize all the nutritional resources? That desire to feed the animals is only as ubiquitous as that sign, right? And so not only can you text the animals, but you can also feed the animals. In this case, with lures that I've designed that are nutritionally appropriate. So they're made from gellan, which is an algae derivative, but they also have a chelating agent in them, a medical grade chelating agent, the same as what you would get treated with if you were hospitalized for mercury poisoning. You would get a chelating agent. So as the fish ingest this lure, the hook is, of course, there is no hook. As they ingest it, it binds to the bioaccumulated heavy metals and PCBs, complexes into this less reactive form, so then they can poop it out, and it's kind of aggregates the small interactions of many people feeding the fish into collective action of remediating the environment. It's a radically different approach that's much more like targeted drug delivery in the kind of medical paradigm, where you're treating the mercury and PCBs where they've been bioaccumulated, right? They're not diffused. In the other side of Manhattan Island, up the Hudson, they've got Con Ed, what's the big company? Sorry, it'll come back to me in a minute. My corporate namescape is failing me. But the biggest Superfund site in all of the US, where after 30 years of legal and legislative wrangling, this big company, GE, finally has coughed up. They're only one of many companies that used PCBs, this persistent pollutant. But they are finally, after all this wrangling, cleaning up the Hudson, right? Which means dredging these so-called hotspots, which are diffused contaminants that have been covered by about 7 centimeters of silt, resuspending all this toxic sludge, and then, of course, shipping it off to Pennsylvania or the nearest third world country, where it continues to be toxic sludge, right? So this idea that you displace environmental problems is the paradigm that we've inherited. And this is what I'm trying to counter with this example, where in situ we are addressing it. By addressing fish health, we're addressing our own health. So, of course, this has led to a whole lot of foods. The Cross Species Adventure Club, which I would invite you to join, is a molecular gastronomy supper club where we explore food and food systems that actually improve environmental health. And I'll show you a couple of examples. The wet kiss, for instance, is a marshmallow for kissing a frog, formerly known as Prince, where the marshmallow, rediscovering the marsh and marshmallows, it also has this violocene in it. Violocene is produced by J. levidum, which is a ubiquitous wetland soil bacteria, where when it's found on the microbial skin community of frogs and other amphibians, And you'd recall that we're in the biggest species extinction crisis since the dinosaurs, with the loss of our amphibian species right now. Those frogs that have gelavidum on their skin seem to survive the deadly chytrid fungus, which is one of the big culprits in creating this species extinction crisis. But so when you bite into the wet kiss, your lips are inoculated with gelavidum, and so you're equipped to kiss a frog and protect it from the deadly chytrid fungus. So there are many other delicious foods like Murkish Delight that increase. Okay, I'm going to finish off with two more projects that situate what we're doing. I want to show you something called the phenological clock. So the phenological clock looks like this. You can see this is actually the cross-species table where we set a place at the table for non-humans. But the phenological clock here, you can see, has all the species in. This is at the Gem Museum in The Hague, where it's a January through December calendar. So when a species, a perennial insect, bird or tree buds, blooms, emerges or migrates, it's marked on the January through December calendar. So essentially it becomes a fingerprint of the local ecosystem that turns our attention from time as a mechanistic representation that is empty and nowhere and everywhere the same, to one that is seasonal and dependent on the environmental phenomena that we, of course, understand as critical. So changing our representation of time to one that turns our attention to natural systems, I would argue, is critical and important for exploring what and how we could finish. So I'm going to finish with showing you one project called Flight Path Toronto, which takes these biomimetic wings. These are strap-on flight simulators that you put onto your hand, and it allows you to use your car as a portable wind tunnel, where you can explore the angle of attack and the maneuverability of, and you know, why it is that all seabirds have pointed wings, whereas birds of prey have these big shovel-shaped wings. So re-engaging the wonder of flight, right? And then once you've done that, of course, you can strap on your 16-foot wingspan wings and fly across wet landings, where we did in Toronto. Here you can see where hundreds of people flew across Nathan Phillips Square through downtown Toronto, past City Hall. They had to come out of flight school, and then I'll just track you through some of this. And of course explored what radically inexpensive, emissionless, fast urban mobility could look like. How we might get beyond the bike lane. So this is what I would call a spectacle of adaptation. This is what I would call a shared public memory of a possible future, a collective experiment, a public experiment like the other ones I've shown you, where when you've actually flown on the Flight Path Toronto, this is your autopilot license. Of course, you sign it yourself. Grandmothers were our most enthusiastic flyers. Actually, I was just going to, let me skip over. I'm going to finish with this one thing. I'm sorry. You could start to imagine what elevators would look like and what goods distribution might look like. So this is, I'll just finish with one case study here, where we take the elevator shaft and we extend the elevator 30% higher than the building, right, to create a view, a beautiful view, where the elevator now becomes a destination to produce a view. But then you put a greenhouse on top of a building, right? That creates a thermal differential, which allows us, with actuated smart sensors that we can now use to turn our vents on and off. We can change and re-access the oldest architectural technology, the shaft effect, so that in the case of this is Tomcat Bakery, we can take the elevator, extend it 30% higher. By doing that, we've got enough thermal differential to replace the HVAC system, right? So we're passively pulling air through without any active work. We, of course, produce access to the roof. We increase the free fall using these next-gen elevators. So now the elevator tips the balance from being 75% more efficient to actually being a micro power plant, generating power for the building, removing the HVAC system and getting access to the roof where we can start to explore what distributing goods would look like, fast, emissionless. Instead of having, in the case of Tomcat Bakery, we have 76 trucks every morning delivering fresh artisanal bread all over New York City, and grime, diesel fume, plumes of it to the local Long Island City residents. Why do we distribute our food in such a way that it gives our kids asthma and degrades the environmental health, degrades our cardiovascular health? This is not a joke. This is about our capacity to redesign and reimagine what it might look like to use emissionless-based mobility to re-access the waterways and to explore some of the exciting and wonderful ways driven with wonder and engagement with these natural systems. How we could redesign our relationship to natural systems to improve our shared environmental health. And I would argue that the best proxy for the common good is our human and environmental health. So anything we do that can improve our shared human and environmental health, let's go for it. Thank you.
Don't be shy. Tell us what you think, please.
Okay. Yeah.
You know, this is incredible, nice things you showed, and but how do you motivate people to do that? I mean, it's you like to do that yourself, and but how a typical person could be motivated? So, you know, if you want to create that transportation system for whole city, so that means that lots of people in the city should participate in that. But if we are not participating, so.
Right. Well, so that's exactly this question of this is exactly the problem that I'm interested in. I would argue that the only reason why there is in Toronto a zip line to school initiative, so the kids weren't allowed to fly on the because of the insurance for this event. And so they formed this zip line to school initiative where they're designing zip line systems to get them, and they've done the research to show that 60% of traffic fatalities in Toronto, it's similar in New York City, I don't know what it is here, 60% of traffic fatalities, pedestrians, right, more than motorcyclists, right? They argue it's safer to zip line to school than to walk to school, right? This idea that you create a public spectacle in which many people are thinking, oh, this is safe technology. It seems ridiculous, If you'd say, okay, we should start to zipline goods around. But if you create a context in which there is a cultural, participatory, public experiment, I think you change who is engaged and how they engaged. And the same with the bio-cha-cha, the same with the tree office, right? Each one of us could explore, you know, we have cell phones and laptops. We don't need to sit in Starbucks or inside. You know, we can sit, we can finish our screenplay or our, you know, novel or our book in a tree. I can guarantee you it'll probably be better, right? You know, exploring, using our own lifestyles as a site with which to experiment and redesign with is, I think, the most interesting way and the most powerful way in which we will address and respond to the Anthropocene, because that's accessing the creative imaginary of many people. It's not about, actually I'll just tell this one quick thing, that I've had two students come to me and say, you know, I print on both sides of the paper, I don't eat meat, I ride my bike, but wouldn't the best thing for me to do be to suicide? Because then I'll have an even smaller carbon footprint, right? And that's the logical extension of environmentalism, conservationism, right? That we've inherited, which is, you know, reduce your harm, do not touch, leave no trace. It's a delusion, right? We've touched everything. So the question is, what do we do? And how do we make that good, right? That agency, that creative agency, I think is the critical thing, inviting people to exercise that creative agency, explore that, is what the Environmental Health Clinic is set up to do.
Yeah, and what I really like about your work is this communication across. I mean, it brings a lot of people in contact, but it also brings people in contact with, you know, the fish you showed or the salamander, and I think that is a very good guiding principle for the Anthropocene. Actually, I think what we now call the internet really needs to evolve into. I mean, we are now talking about the Internet of Things that includes fridges and cars. And the products Amazon wants to send you with the drones in the future. I think what you describe should lead to an internet of all things alive. So an internet that really connects us with non-human life on Earth through sensors where we can really communicate. And I mean, you can do that without an electronic internet. You know, there are many analog channels, and my new book is called The Analog Revolution because of that. But I think what you show is that we really need to head towards communicating in a deeper sense and see nature not as objects anymore, but as subjects. And I think that is the great transformation, is seeing agency, or what you describe as agency, so turning the natural world into subjects and not objects anymore.
Sir, I want to know what are the consequences? Can you enlighten me the consequences of accepting the automation in natural things? Like in the presentation which you said, like we can use the automation and robotics things for automation of animals. And what are the consequences which can be raised in further? Like as a random example from the mobiles, whatever, the telephones from which we got mobiles, and we forgot the era of that, like the origin of this, and it can affect the nature by accepting such kind of things. Can you just enlighten the consequences in that?
Sure. Well, I think what is really important to see that I mentioned the geosphere and the biosphere in my talk, and they are very good at kind of recycling their components. Now, the technosphere we have built up so far is not very good at doing that. And I think that's a huge task. And the mobile phone example, I mean, I would dream of a mobile phone that is compostable, or of a car that is compostable. So of technology that is, in that sense, organic. There are dangers of that, and I mean, we see the US military exploiting bionics for its own means and building, the weapons of the future, inspired by hummingbirds, for example. But I think we can, for the future of technology, we can draw a lot of inspiration, and that will probably lead to solutions that are perhaps very, very simple and will improve the lives of many people. You want to add to that?
Yeah. Did you want to? I think it's important to add that there is a repertoire of a vocabulary of technologies that can address this issue. So it's not just about projecting, and which we've done, particularly in the 70s, and this idea of projecting consequences. That's uninteresting, right? We don't actually know what the consequences are. That's the problem with the Anthropocene. It's an irreducibly complex context in which we don't know what the consequences are. But we do have some technologies that are promising and important. And in terms of recycling metals, just cobalt, for instance, it's just insane. And to see that you remove a mountain, effectively, to get a couple of kilograms of cobalt, you put it in cell phones and then you throw them away, is crazy, right? There's a new plasma, small-scale plasma technologies in which we can do that. We could set them up in the university here, now, and explore what it looks like, right? So I don't want to kind of continue the discussion of the Anthropocene as we have talked about global climate change, right? Which is this massive phenomena that, what do we do? This is scary, right? But looking at, what are the recycling strategies that you can start right here now? As a student in this university right now, what kind of circular recycling system could you start building? Could you start creating? And that's, I think, the important thing to take from this, this framework, is to say that it's an invitation to reimagine, redesign, and develop your own consequences, actually, to create the desirable future that you want, right? That we are driving, right? So we can drive with our eyes closed and our foot on the pedal. Or there was a great example with all the funding that goes to the ice core, the climate paleontologists, right? The example they gave was, that's like addressing the climate crisis by putting your foot on the pedal and driving down a freeway at full speed while only looking in the rearview mirror, right? But this idea that we are driving, so let's open our eyes and let's drive, right?
More questions? Yeah. Microphone is coming, yeah. Thanks for passing it on, that's great.
Okay, thank you very much for some very interesting insights. I still am left wondering whether what you say is really a significant step forward instead of still trying to keep things up as they were. Like, for example, I really don't believe that you would believe yourselves that planting some trees on rooftops can really somehow compensate the deforestation problem. Or having a couple of butterflies in a town would really somehow prevent them being distinct or not seen, or maybe cleaning, a small area of air would really bring in any significance to the wider scene as we see it. Do you really have ideas probably for a next step, or maybe something really significant? Do you really think that that is sufficiently significant?
Can I say something? I think what I really like about your project is exactly that humbleness and that incompleteness, and that it makes you really see the complexity of what happens in nature. Once you try to engineer it, to build it, to replace it, to repair it, you start to feel how much you need to repair and how complicated, how expensive it is. So what Natalie does for me exactly with this impression opens the eye to what is the analog complexity of the natural world and how careful we have to be when we deal with it. But, sorry.
Thank you for the blunt question. And yes, I actually do believe that when you are designing in irreducibly complex socio-ecological systems, the only way, the only viable way to go forward is to do these small experiments. Because they are irreducibly complex, because, you know, the climate models that inform the carbon sequestration, geoengineering, scaled, maybe the things that you prefer, are bullshit, right? Their scale, their cell size, their pixel size is the size of Kansas, right? That's the level at which you're representing these complex, mutualistic, fragile, specific, irreducibly complex relationships. Do I think that we should have mussel cultivation in and through, up and down each urban river? Absolutely. Do I see that the amphibious architecture array, the little buoys, that actually foster and create mussel habitat, and therefore fish habitat and algae habitat, and I can tell you that's by far the cheapest way to do water treatment. That the $3 billion water treatment facility up the river won't function as well as if we had a massive megametropolis of mussels. So I can only work on a very small scale, but I can work with high standards of evidence at that scale, and with that demonstrate the capacity to scale. And I would rather scale with high standards of evidence with things I know work, because I can tell you that figuring out that a living infrastructure works on the East River doesn't guarantee that it's going to work half a mile up the same river. It doesn't guarantee it's going to work here in this river. And the only way to do it is to try it. So this experimental paradigm gets us out of the analytic paralysis of scaling at system scales that we have no agency over, that we have no capacity to design, that we have no accountability to. And if we did reframe the Anthropocene in terms of what can I do in my neighborhood to reduce my child's risk of getting asthma, we would go a long way towards addressing it. And I think that's why the Environmental Health Clinic, I have 11 of them opening around the world. Young designers and people have said, okay, I'm going to spend, I don't know how to fund this yet, but I'm going to hang out my shingle and be an environmental health physician, and I'm going to figure out how to redesign the food systems just in my neighborhood, just where I can act, just where I have agency. And I'm going to work on where I can act, because I'd rather, you know, it may not work, but it might. And I'd rather figure out the things, you know, work with what we can do than these paralyzing representations that tell us that anything we do is insignificant. I just don't buy into that view of human agency, and I think we're responsible for creating our own desirable future, and I don't think the politicians are going to do it. So if you and I don't do it, and if this generation doesn't do it, then, you know, and frankly, I think, you know, a big idea of energy to transition to small-scale distributed local power production, that's the only thing that can work, right? Okay, maybe you want more coal-fired power plants or nuclear plants. But I know that distributed local power production works to increase human health benefits, to increase air quality, to provide energy for energy-intensive lifestyles. Why not build those? Why not explore them? Who says the municipalities should be doing it? Municipalities aren't the ones that can innovate. Certainly states aren't innovating, and certainly international organizations aren't innovating. So where we have agency, where we can act and where we can experiment, is where we can explore what is viable, what we can do. And that can scale through the aggregation of high standard evidence public experiments, not through some market policy of carbon trading or setting some price at the right, which frankly has failed, is probably going to fail. And if you're waiting for COP21 in Paris in 2015 to address this, if that's the alternative of a scaled, unilateral, international agreement to address the Anthropocene, I'm glad, but my money's not on COP21. My money's on, if I was placing a wager, my money is on the creative agency that each one of us has to do small-scale change and aggregate that into tremendously significant effect. So that's the bet I have. Maybe you'll bet against me, but that's okay.
Super.
Yeah, no. I mean, yes, that's the criticism I get. It is on a municipal scale. To the biochar, was for Long Island City residents. It's all funded through arts organizations at very, basically at no money. And no, frankly, the engineering, I'm an engineer. I think this is the way to engineer our municipal systems through participatory public experiments. Enlisting the Army Corps of Engineers and the stranglehold on the public purse one example, I think, the scaling problem. Yes, I actually believe and would argue and have white papers on the benefit of using the buoys to support mussel cultivation and fish habitat and local remediation, and that should be wrapped around the entire shore of New York City, 200 miles of New York City coastline. Frankly, that would be the best way to form a resilient shoreline, or what I call the unshoreline, so that in the wake of something like Superstorm Sandy, which comes along, you've got a massive mussel colony that absorbs the wave energy, right? So yes, it can scale. The public purse has a stranglehold by large multinational environmental engineering firms that win big contracts that are millions and millions and millions of dollars versus, a $1,500 grant from an arts organization. So it could scale, but the way that my projects, for instance, the pharmacy ag bags, which can have a significant effect on air quality in an urban context. In fact, a 10-fold increase in leaf area index, which we can achieve very easily in this radically inexpensive way with the ag bags, would significantly you would see significant effects on cardiovascular health and hospitalization rates within 1 week of doing that, right? So it can scale, but the question you're asking me is, I think, an unfair one. I mean, I can do what I can do, and the question is, open an environmental health clinic and do things here. That's how it scales, right? That's how it, talking to municipalities and developing community boards, getting some of the funding that currently goes to environmental engineering firms could scale. So I don't know, that it's set up to scale, and it does scale in this participatory, person by person way, right? I suppose.
I would like to respond. I would like to respond to that question of scale, because first of all, I think Natalie's work reaches audience on the larger scale, but not necessarily as artifact, you know, but precisely as the pedagogical model. Because by reaching the audiences, first of all, through the classroom, through the student, you know, it reproduces, you know, itself, and that is very powerful, you know. Then again, speaking about the artworks, we are speaking, you know, every single work of art, you know, is a small model, you know. It's not meant to be massive kind of like scale, you know, distribution, you know. That is entirely different project then, you know. So if you look either at the history of art, history of architecture, history of science, we have models, you know, we have instances, and you know, and they reproduce, you know, through pedagogy, you know, but not necessarily, you know, they would reproduce through the governmental agencies, you know, or through kind of like, you know, real estate development plans, you know, for example, you know. So for me, kind of like, you know, to think about these instances as models is very powerful example, you know. As models often, well, and just to add to that, you know, models always work with scale, you know, as a conceptual ground, you know. And models always have one foot in reality, because they're real, you can really almost tangibly kind of like perceive them, sometimes even touch them, and they function, right? But we shouldn't forget they're not necessarily reality. You know, they still function on the level of, you know, of being a model.
Two quick sentences in response. My Anthropocene vision would be I mean, Natalie talked about carbon pollution and the wonderful pencil project she has. Governments worldwide still spend $500 billion annually on subsidizing the production and consumption of fossil fuels. Now take that figure, $500 billion annually paid by governments to make fossil fuels artificially cheap. So they are cheaper than renewable energy. So my dream would be that these subsidies for fossil fuels are removed to make visible the real price of carbon, and then you add the damage it does to health and everything else, and suddenly fossil fuels are so expensive that that a lot of money will go into investment in renewable energy very fast. And second thought, I would dream of an Anthropocene world where people line up in front of Natalie's health clinic like they line up in front of Apple shops when the next iPhone is released.
I know there are a lot more questions out there, but I think we must end. One more? Is there one more?
Oh, well, then
okay.
I'll ask a very short question.
Okay.
No, I enjoyed both conversations, so thank you very much. But I'd be interested in the question of values. Like, what are the values that underpin some of the amazing enthusiasm and drive that you have for making these shifts and changes and turning things around?
Thank you. That's a really great question. I think it's a great one to end on, that we could maybe all... I've actually avoided sort of, I suppose I've made a policy of avoiding two things, ethics and values explicitly. And translating, in my case, the the polarization that comes from that. So you can have people who are pro-development and anti-development, who are techno-fetishists and, you know, Luddites. You can have right-wing and left-wing. But no one's anti-health, right? And this is why I use and validate my work not on aesthetic or, you know, number. You know, the number. It's actually just on finding the best proxy for the common good that I can find, that is measurable, that is tangible. And I would say human environmental health is the proxy for the common good that I use, that allows me to transcend the kind of cultural, ethnic, class issues that involve any kind of work in public space or shared public space or in our environmental commons, our air or food commons, right? So I explicitly avoid speaking about values or ethics with that strategy in order to be able to facilitate the kind of distributed and, you know, with the butterfly bridges, the kind of public discussion that and learning that I get from actually setting something up as a material public experiment is that, you know, all these people, children, tell me, oh, you should put this in. I've seen the plants that the butterflies really like, and you know, you can draw on so much more knowledge if you have it in the context where the values are shared but not polarizing, if you will.
Perhaps two kind of values that are motivating me. One is, I think, a respect for every form of life, because if you look around in cosmos, you know, life is pretty special. And I think in the Anthropocene, we are now having derived our modern life from disrespecting life in a lot of instances, and from not valuing life around us. So as a biologist, you know, I look at a cell and I'm, you know, just a single cell, and you know, it can really touch you. And the second thing is, I have a strong environmentalist background in a sense, but this feeling that humans are bad for the environment, I think we really need to overcome that, especially in a world where we will be 11 billion people. And there is nobody who can say, you know, you are too much, or I am too much, or Natalie is one too many on this planet. So who will decide? So I think we need to found the new environmentalism on anthropophilia, on a love for humans being on Earth, and making a long future for humans on Earth. And that's perhaps what you know, makes me so interested in the Anthropocene.
Okay, I would like to thank, first of all, our speakers for their fantastic presentations and opening up very important themes that we're going to discuss in the next series. And the next one is next Friday, December 12th, with Caleb Harper and Skylar Tibbetts, both MIT scholars. They're going to further inquire and reevaluate theme of nature. So thank you all for staying with us tonight, and once again, thank you our speakers.